right, so for your DNA mutations worksheet, let's look at these directions. First thing it says is transcribe and translate the original DNA sequence. All right? So actually, if you have highlighters or colored pencils or something, you might want to take a second and get those out real quick. All right, so the directions tell you that you are going to do this with the original DNA sequence for this whole worksheet, okay? For this whole worksheet, this is the original DNA sequence. So for every example, or for every problem, you're going to compare this mutation sequence to this original DNA, all right? So this is what it should have been for every single person. All right, then the directions say that you are going to transcribe. Transcribe is step 1 in protein synthesis, right? Translation. What do you get at the end of translation? What do you make from translation? Yes! Thank you. RNA, okay? So translate. We're going to translate that first. Then we are going to translate. What do you make at the end of translation? A protein or the amino acids. All right, so let's look at our mRNA transcript. All right, and let's figure this out. So T bonds with, A bonds with, C bonds with. Next 3 should be, good, U, G, G. Somebody who's not PJ, shout out the next one. A, C, very good. Somebody else. C, G, C, very good. Next one. U, G, C. And last but not least, U, G, A. Very good. Now, I gave you a codon chart and the abbreviations on the back of your worksheet. Okay? So for the process of translation, we need to figure out each amino acid that the mRNA stands for, right? So the first one's AUG. So you flip this over. A, U, we look for G, is what? Methionine. All right, and the abbreviation for methionine is MET. M-E-T. So right here, we're going to put what? MET. What's the next one? UGG. U, G, G codes for tryptophan. Very good. And tryptophan is abbreviated TRP. So we go over here. TRP. Next, what does AAC code for? Anyone? What's the abbreviation? ASP? Is that right? ASN or ASP? Next one. Okay, so we keep using our codon chart. Our next one was arginine. What's our next amino acid? CYT. So cysteine. And our last one codes for what? Stop. Very good. Right? And we get all of those from using our codon chart that looks like this. So this now is how the DNA should have looked, what the mRNA should say, and what our protein should look like. We all get that? Nod your head yes if you get that. Sweet. So now we're going to look at each mutation and figure out what kind of mutation it is and what problem it caused. All right? So here's our first mutated piece of DNA. If we look at it, we can see, are these two the same? Yes. So TAC, what's next? ACC, and what does ours say? So is that a mutation? Yes. So we know our mutation is right here. All right? So now we can do our mRNA, right? So the first one is AUG.
It's the second one, not the third one.
Oh, thank you. I should have underlined here. Thank you. That's where the mutation is. Here is different than it is right here. Okay? So AUG, what's our next mRNA going to read? UAG, AAC, CGC, UGC, UGA. Okay. Yes. I thought so. CYS. This is why I like it when you know what you're doing, you shout out the answer. Thank you for fixing that. All right. What does it say right here below mRNA transcript? Circle any changes. So what is changed from this one to here? This one, right? This one's different. So you circle it. Last but not least, what's our next step? Amino acids. So what does AUG code for? Methionine. MET. What does what does UAG code for? If you look at this, very good. UAG codes for stop. So you would write stop. So that means your ribosome says, all right, we're done. Do you think that's going to be good for your protein? No, because now your protein's only one amino acid, right? So we look here. What type of mutation is this? Is this a point mutation or a frame shift mutation? Good. It's a point mutation. Because we substituted what? A C for a T. C for T. Or T for C, I guess, actually I should say. Either way, you get it. There's a different letter, right? What happened to our amino acid as a result? Was there no change? Was there one amino acid changed? Was there a premature stop signal? So then you circle this one. All right? And then that's what you do for each one. So now you guys will look at this mutation and compare it back to the original DNA to answer the questions. All right? So I want you to work with the people around you and really practice. Try and get the next 3 done so that you can ask questions in case you get stuck and stuff like that. All right? All right, there you guys go.